Hey guys, welcome back from Christmas break, from the holiday break. You should be rested and ready to go with math again. I know how excited you are to get started with math again. Okay, you can stop laughing now. All right, let's look at our next lesson in Unit 4. Remember, we had 2 lessons in this unit that we were going to come back and do after the holiday break. So here is our next lesson, and it is about quadratic functions. Quadratic functions are when you have a squared term. It says the greatest power of the variable is 2. So on a variable, you're going to have 1 that is to the second power. Okay? That's what a quadratic function is. It sounds very complicated, but it's not. So let's look down here at this graph, and we're going to talk about true and false. Well, first of all, I want you to notice this. A quadratic function is a U shape that can open up or down, and here's how you know the difference. If it's a negative on the squared term, then it's going to open down. Okay? If it's a positive on the squared term, then it's going to open up. So you can be able to tell that automatically just by looking at the squared term, whatever variable has the 2 on it. And if it's positive, it's going to open up. If it's negative, it's going to open down. So let's look at the true and false questions. It says a function in which the greatest power of the variable is 2. Is a quadratic function that? Yes, it is. We already read that, in which the greatest power of the variable is 2. So that is a true statement. You're going to have a squared variable. Excuse me. Let's go over to this one. It says the graph is a straight line. Well, we already know that it's not because it says the graph is U-shaped, and we've already drawn 2 U-shaped examples. So that is false. It's not going to be a straight line. It's going to be U-shaped. Okay? The graph always opens downward. Well, we know that that's a false statement because if it's positive on the squared term, then it opens upward. So that's false. And a graph of a quadratic function sometimes opens upward. That's a true statement. It doesn't say it always opens upward. It says it sometimes opens upward. And that is true. Okay? So now let's look at the example that they give us. It says Chris kicked a soccer ball straight into the air. The height in feet of the ball after t seconds is found using this equation. Right here, it has a squared term, so we know it's going to be a quadratic function. We know that it's going to be U-shaped, and it's a negative on that squared term. So we know that the ultimate shape of this graph is going to be downward because it's a negative on the squared term. And then it says, what is the height of the ball after 1.5 seconds? Well, in order to do that, we have to plug, this is time, so we have to plug this into t in our entire equation. So I'm going to do the work for that on a separate sheet of paper. So here's my original equation. I have a negative 16t squared plus 40t plus 2. So here's my original equation. And what it's saying is it wants to know what is the height after 1.5 seconds. Well, I have to use 1.5 in all of the places where I see a t. So I see a t here, so I'm going to replace that with 1.5. I see a t here, I'm going to replace that with 1.5. So now what I have, I'm just going to replace the t's with 1.5. This first 1.5 is squared. 40 times 1.5, and then plus 2. Okay, let's work this out step by step. Well, first of all, I want to take 1.5 squared. So on your calculator, hopefully you have a calculator handy. If I type in 1.5, so I have 1.5, and then you square it. That's this button right here, okay? So if I hit that button and then equal, that tells me that 1.5 squared is 2.25. Okay, let's do that again, and I'll do it slower so that we can all see it. If I type in 1.5, okay, you see the 1.5 on there? And then I square it, which is this button right here. So I hit that so that there should look like there's a little 2 beside it. And then equal, it's 2.25. So I now know that this is negative 16 times 2.25 40 times 1.5. So again, I take 40, clear that out, 40 times 1.5 is 60. So this is plus 60 plus 2. Well, now I have to take the negative 16 times 2.25. So we get on the calculator, do a negative 16 times 2.25, and that equals a negative 36. So I have negative 36 plus 60 plus 2. And let's work all that out on our calculator. I have a negative 36 plus 60 plus 2. And that equals 26. So after 1.5 seconds, the ball is 26 feet in the air. Okay? So now let's look over here. This is a graph of a quadratic function where they have put in some points and they've solved it just like we solved this one. Okay? They put in the points where the t's were, or in this case where the x's are, and then you solve for it. So let's go down here to the first got it problem. And we're going to actually graph an equation. So here's my equation, y equals 6x. Again, I'm going to do this on a separate sheet of paper. I want to have an x column. I want to have a column where I do my work, and it's y equals 6x squared. And then I want a column that I have my y in. Now, because this is a positive number on the squared term, we already know that our graph is going to open what? Up or down? Well, hopefully you know that our graph is going to open up because this is a positive number. But let's actually do it and figure it out. It doesn't give me any numbers to use. It doesn't say plug this, 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 and this in for x, so we're going to use negative 2, negative 1, 0, 1, and 2. Excuse me. So first I'm going to put a negative 2 in there. So I have y equals 6 times a negative 2 squared. Negative 2 squared is a negative 2 times a negative 2, which is a positive 4. So I have 6 times 4, which is 24. So my first y is at 24. Whew. That's way up there. Okay? Let's do some more to see what else we can get. Let's do a 1. I put a negative 1 in for x. A negative 1 times a negative 1 is 1. Negative 1 times negative 1 is 1. And 6 times 1 is 6. That looks a lot better. So this first coordinate is a negative 1, 6. My x is a negative 1. That's my first number in the coordinate. When I solved it, I got y is 6. That's my second number in the coordinate. So I'm going to graph negative 1, 6. Negative 1, 1, 2, 3, 4, 5, 6. Okay? Now let's do 0. Put a 0 in for x. So I have y equals 6 times 0 squared. 0 times 0 is 0. And 6 times 0 is 0. So now my x is 0. I'm going to make another column over here of our x and y's. My x is 0. My y is 0. So I have a point at 0, 0. Okay. Now let's put in a positive 1. Y equals 6 times 1 squared. 1 times 1, again, is still a 1. So my y, when I solved it, 6 times 1 is 6. So my x is a 1. My y is a 6. So I have a point at positive 1, 6. Well, now you can see what the shape of this graph is going to be. It makes an upward slanting line. or an upward U that looks like that. Okay, so there's our graph for y equals 6x squared. All right, this next one, it says, here's my equation, okay, and it says, use the graph to find out how much it will take the race car to travel 200 feet. So 200 is what I want for my D, because it says how long will it take for it to go 200 feet. So I can graph this. It's broken into 0, 1, 2, 3, 4, 5, 6, 7. So that's what I would use as my T. And then plug that in for 4 times square your T. So where T is 0. 0 times 0 is 0. 4 times 0 is 0. So I have a point at 0, 0. Put in a 1. 1 times 1 is 1. 4 times 1 is 4. So I have a point at 1, 4. And so on. And then I would go all the way up. And you would see that at 200, it takes 7 seconds to go 200 feet. Okay? So let's do this one. It says the outdoor observation deck of the Space Needle in Seattle, Washington is 520 feet above ground level. Use the graph to estimate how far you can see from the observation deck. Well, this is how far up you are on the Space Needle. This is how far you can see. Okay? So we need to find 520. Well, here's 600. And then it goes by twos. So here's 100, 200, 300, 400, 500. And we went about 520. So let's call it about right there. And I'm going to draw a line over to where it intersects the graph, and then draw a line down. And it says estimate, so we don't have to be exact, but if here's 20 and here's 30, that line in between is 25, so it's a little bit above 25 but less than 30, so we're going to call that 27. It's about 27 miles is how far you can see. Okay, all I had to do was find 520 on that graph and see how far I could see whatever that intersects the line. All right, if you guys have any questions, make sure you bring your questions in and let us answer them. Otherwise, have a great night. Talk to you later. Bye.